Hey there guys, I just wanted to come to you today and give you a quick run through of the guided oscillation lab. Here you're going to be seeing we have 14 steps to go through, and there is also a document that I created on Schoology that you can put your answers into and add anything you need to or take away from. I would go ahead and I put most of the things in there you would need to be recording. If I miss something, just go ahead and add it in, okay? So step 1 and 2 up to about 4, they're just telling you how you would set this up in a real equipment. And it tells you right here, when you use a real equipment, make sure the mass is at least 40 centimeters from the sensor. This is a little green box, is that sensor you're looking at. And here on this step, it tells you you'd be pulling the spring down. So what you're trying to do here is actually measure the oscillation and the frequency of what this spring is going to bounce up and down as you have a mass hanging from it. Now we go ahead and see the motion is moving. This spring is bouncing up and down. And of course, it's pretty solid movement because this is a coded thing where your sensor's reading it and the computer wrote all this down. And you're going to be able to start doing data collection. It says right here, if you're having trouble, you would add an index card to this, so we're not going to worry about that step. Here it tells you a certain frequency of oscillation. That's in cycles per time, or number of cycles over time. That would be, you're measuring how many times this spring goes up and down, up and down, up and down. You can actually visualize a little easier on the graph here, as we see it, a position time graph. I can recollect it, and you can see as this is bouncing up and down, so is the sensor seeing it as it moves up away from it and towards it. And then you see it starts around 40, gets closer to it, then farther from it, closer to it, farther from it, closer to it, farther from that little green sensor right there is what it's reading from. So the cycles per time, remember a cycle is a complete up and down, so all the way back to the original, past the up and back down. So one cycle all the way up, back down. That's one cycle right there. This one just tells you to go ahead and figure out how to do it using the calculator and the graph. So all the way from here, all the way up and down, that's one. That's that's hard to read since we're not getting a good time here. Let's just keep counting until we get to a pretty good spot. 1, and then where's the next one? 2, 3, 4. Well, looks like we're going to hit a good spot, so we could actually go all the way to the end if we wanted to, but in reality, you just have to count. So 1, and it's right here is where we're going to say it's landing. And what does that fall under? Between 0.5. So what are these markings are? They're all 0.1, 0.1, 0.2, 0.3, 0.4. So about 0.45, I guess you could say. And that'd be one cycle. So one cycle divided by 0.45. What does that come close to? Well, this is the answer we're looking for. Did we get close to that? You're going to have to see whether or not. And if you're not close, you're going to have to adjust your number to get closer to that. And know that you're doing a little in between each one of these marks each time. So on your next step, you're going to be moving and collecting frequency for different steps, and you have to record this on our sheet that I asked you to record it on. Let me go over to that one real quick. There we go, unpause, and here we go again. So here's the rest of the activity. This is that sheet I was telling you about. You can actually move up or down on this and see I added some stuff in there for you to do. And since you're going to be finding an unknown mass, we actually would need to add something in there on that 200 part to make sure we get there. And I'll take care of that just in case later. If not, you can add it as well if you've already done this part, and put your unknown in there. So just make sure you're putting your numbers in there. So our amplitude would be going in the amplitude. That'd be counting from the top to from the middle up, or from the middle down. That's what you're looking at there. The number of cycles, what we just did. We did the time. That's how many cycles you counted. And then you did frequency off that. That's what we found. And then period you would determine from the frequency using the equation up in this line up here. And let me go back to the other one now, and we'll keep going on that. So for this next step here, let me move this one out of the way. All right, for this next step, we're going to go to step 9. Step 9 says it's the second mass. You can see this one's a lot heavier. It's got a higher mass, 300 grams, so it's going to get a lot deeper wave motion. And we're going to see it's producing a larger wave with a larger amplitude and a lower frequency because it's taking longer to go up and down because it's going a longer distance. If we want to watch it again, here we go, watching it again. You'll see this as well whenever you're going to do it. Doing the same thing, calculating all those numbers. Smaller mass, smaller waveform, quicker frequency because it's going to be able to make those movements quicker. Here, somewhere in the middle, here you go, you got another mass to testing it out again. We're trying to refine that number down to getting it perfect. 200, we got another one here to see what it is and see where we're graphing our data. Here it just tells you what you need to do, leave it in hertz and grams. I told you to do that as well. And you can graph them on the X and Y axis as well using a XY graph on your document or on a piece of paper. And here's our unknown mass. We would use the graph again down here to measure and see about what our mass is going to be. We should be able to get pretty close to accurate on this using this unknown mass because we've got a pretty wide range of numbers to get close to our idea. So if you're just going to estimate it here, that's fine. You don't have to get it perfect, and that will be okay. So good luck, and see what you get here at the end.